everyone, this is Sirius back here again with another video. Today we'll be looking at a question from the 2018 Pure Chemistry paper, and this question is from paper 2, question 4. Right, so let's take a look at this question now. Methods and solutions of ionic compounds conduct electricity differently. Part A. Describe how methods and solution of ionic compounds conduct electricity differently. Alright, so for this you have to be very particular because the technical terms are very different when it comes to the electricity conductivity of metals and ionic compound, right? And most of the students tend to write the wrong technical terms, leading to them not able to obtaining the full marks, or sometimes not even any mark for this question, because a lot of students like to mention about electrons being the electricity carrier for ionic compounds, and maybe sometimes some students will write ions as the electricity carrier for the metals, right? So let us clarify this today once and for all. Right, for metals, recall that the structure of metals looks like this, right? And all these are actually positively charged. Okay, so it's a sea of it's a positive ions, right? And you have all the small little dots in between, right? So the big circles, these are the positive ions. As we know, metals tend to form positive ions, right? And the small little dots in between, these are the delocalized electrons, right? Or we call it the free moving electrons, right? So in metals, these are the electrons that are actually moving the electricity around the whole metal. Alright, so for this we can straight away mention that metals conduct electricity using delocalized, or if you have problem memorizing this term, you can also mention free moving electrons. Right, so we have already mentioned about the metals part of this question. So how about solutions of ionic compounds? So remember that for ionic compounds, they cannot conduct electricity in the solid state. And why is this so? Because in the solid state, the ionic compounds, they actually have the what we call the giant lattice structure, right? So this is the giant lattice structure in 3D. Okay, right, and you roughly know how it looks, so I shall not finish drawing. So you can see that in solid state, these ions here, all these are actually locked in their position and they are unable to move. When you have ions that are stuck in their position, nothing is moving and the electricity cannot be passed through this whole compound, right? So in that case, solid ionic compounds are not able to conduct electricity. However, when we are talking about solutions of ionic compound, or we call it the molten ionic compound, right? Now they are able to conduct electricity because the electrostatic force of the ionic compound when they are in molten form will no longer be there. It is already overcome by the heat energy. Hence, now all the ions that are previously locked in the ionic compound in terms of the solid form is now free to move around. And when the ions are free to move around, now they will be able to carry the electric current and move all over the place, which then leads to it being able to conduct electricity, right? So for the solution of ionic compound, it goes like that. Solution of ionic compounds use free moving or mobile ions to conduct electricity. Alright, so that is how you go about solving this question. For part B, conduction of electricity can have a different effect on metals and on solution of ionic compound. Describe this difference, right? So think about electrolysis. Okay, recall electrolysis chapter. There is this particular electrolysis, that is the electrolysis of molten binary ionic compound. Okay, so what happens when electricity passes through this molten binary ionic compound, right? Solution, for example, solution of the ionic compound is actually broken down into their elements, right? So when, for example, if we do electrolysis on molten sodium chloride, you will actually have the sodium ions moving towards the cathode to form sodium metal, and the chloride ions moving over to the anode to form chlorine gas. However, for metal, it does not happen like that. When electricity is passed through metals just remains at itself, right? It doesn't break down into any other components or any other elements, right? So this is the major difference between the two, between metals and solution of ionic compound, right? So we will go about answering this question this way, right? When electricity is passed through solutions of ionic compounds, it breaks down the ionic compound into their elements. Matter remains as it is. Alright, so when electricity is passed through solutions of ionic compounds, it breaks down the ionic compound into their elements. On the other hand, matter remains as it is. Right, so this is how we solve this question.